Yeah, okay. All right. So thank you all once again for taking time off your afternoons to just attend today's sharing. Yeah, in a joint collaboration with OGP, EnginClub is actually very happy to have Sarah and Preston to share more about the company and more on the topic of what a career in software engineering in OGP would be like. Yeah, so to give you a brief introduction of our speaker today, who is Preston, he graduated with a bachelor's degree in biomedical engineering, and then subsequently he moved on to take a master's in computer science in Stanford University. Yeah, so now he is actually working as a software engineer at open governance products for close to 4 years. Yeah. So the flow of the sharing will be hearing more about OGP, what they do, more about what products they have produced, and then Preston will share more about his role in OGP as a software engineer, and also he'll just give some advice for the students who are actually interested in pursuing a career in software engineering. Yeah, and then lastly, we'll just end off with sharing of a Q&A segment. So if you have any questions, feel free to stay tuned to the end of it to ask, okay? Yeah, and if you would like to receive more of these contents, please feel free to subscribe to EnginClub's platforms. We have our Telegram announcement channels and Instagram page. Yeah. Okay, so without further ado, I'll pass the time to Preston and Sarah. Yeah.
Hi everyone. Hi. I'm just gonna quickly share my screen. Also, if throughout the presentation, if you have any questions, feel free to just drop a message into Slido or the chat, and I'll get to you in a bit. Okay. Okay, are you able to see my screen? All right, cool. So, hi everyone, I'm Preston Lim. I'm a software engineer, and I currently work in Open Government Products, which is a division within GovTech. And I'm going to talk about getting a head start in a career as a software engineer. So just a really, okay, there we go. So a really brief overview of what this talk is going to be about. I'm going to start off by talking about my work today. First, by talking about what the various products that we built in OGP for government. And then I'll talk about a little bit about my stumble into software engineering, because that wasn't the instinctive choice for me as a career, because I never thought I wanted to do more math or more engineering after JC. And then I'll talk a little bit more about how to get a head start. And there are two main points about this. The first is, do you even want a career in software engineering? And I wish someone had told me what the career looked like, and maybe I would have picked it sooner. And finally, if you know that this is a career that you want, how do you then become a better software engineer? Okay, my buttons are not working, so I'm gonna just click. Cool, so I'm gonna start by talking about my work at OGP, and I guess our mission for this whole team is to build tech for public good. And if, for example, I'm just gonna walk through some of the products that we've built. You might be familiar with some of them. If you've taken a vaccine dose, Pfizer or Moderna, in the past couple of months, you would have definitely used one of our systems. So we built a bunch of COVID-19 operation tools, such as the national appointment system that allows you to book your 2 doses of Pfizer or Moderna. And if you use Trace Together, for example, the vaccination records within that app is also fueled by or powered by the vaccination project that we've worked on. Another thing that we've built for this COVID-19 crisis is Homer. And Homer is a quarantine enforcement system that helps reduce the spread of COVID-19. And we do that by ensuring that people who are supposed to be on quarantine orders or stay home notice are indeed where they are supposed to be. And so we started off with sending spot check SMSs with our first system called Homer SMS, and that was done 3 times a day. And we started realizing that sending 3 location tracking SMS links per day is not enough. So we then proceeded to building a full mobile app that allowed our quarantine enforcement officers to get someone's location every 5 minutes. And these individuals can also submit their health reports so that we can go help them if they do have symptoms of COVID-19, and as well as a kind of selfie face recognition tool that allows us to verify that they are indeed the people who are supposed to be submitting these health and location reports. Yeah, so across so we've helped over 300,000 users across 4 government agencies in the past year and a half. So it's been quite a significant project that I was a part of. So outside of COVID times and more, I would say, normal times, we also built a suite of tech products for government. And this is one of our biggest projects. It's called FormSG. And what FormSG is it's essentially a Google Forms, but for government. And the main idea behind it is to remove paper submissions and get rid of all inefficiency in that sense. So the main difference between FormSG and, for example, Google Forms is that FormSG has integrations with our government identity providers like SingPass, and that allows more seamless transactions with other government tools. So another product from our team that you may be familiar with is Parking.sg. And what Parking.sg is it is an app basically that's meant to replace parking coupons submission coupons. So you don't have to go and buy physical coupons and then put holes in them and then lay them on your dashboard. And instead, what you can do is you can just download the app and then pay for it. And that reduces the inefficiencies and the pains of having to deal with something physical. And finally, this is a project that I'm currently a tech lead for. This is Isomer. It is a government website platform that I'll be talking a bit more later. So now that I've talked a little bit about OGP and the work that we do, I'm going to share a bit more about how I even got into this role, or more specifically, how I even got into software engineering. Because as I mentioned earlier, it wasn't entirely intuitive that software was a career choice for me. I went to college at Stanford University in 2013, and I took an EDB scholarship. So I was quite certain I wanted to be working in public sector for government. And at that point in time, I thought I was going to study economics. And I mean, that's why I took the scholarship in the first place, because I wanted to do economic development work for the government. And then I realized in college in my first year that, wow, okay, I hate economics. It's very, it's not my jam at all. And I wanted to do something more technical, more mathy, more engineering heavy, and which was a huge contrast to what I thought I was going to do, because I told myself I would never ever want to do math or physics after JC. But the way that it was taught was very different, because it's framed in a very problem-solving heavy kind of way, and that was really what piqued my interest. So here are some photos from my time. So this is a kind of a leg model that we built for one of my lab classes, and the project here, this is basically replicating a human leg, and what we built right here is a deep vein thrombosis preventer device that you would wear hopefully on airplanes, and it would kind of squeeze the blood up so that it prevents thromboses from forming in your legs. And for all those who are familiar with DVT, it could be life-threatening, and it could cause clots and then stop your heart. Yeah, so that was something that was really cool, that I really enjoyed. But also in college, I discovered my love for opera and musical theater, and I thought I was going to do a minor in music performance in my second year, or I was even thinking of doing a master's in opera. And so that's me on the bottom right. That was me in Into the Woods, and that was me in Rent. And if you guys are Broadway fans, or if you've seen Glee or Schmigadoon, this is Kristen Chenoweth, and I was her backup singer for her California leg of her tour. So that was really cool. Yeah, so most of you must be thinking at this point, where on earth is this guy going with his talk, right? How on earth did he end up a software engineer? And this is why I say it was kind of a stumble, because at college, I knew a lot of people in software engineering degrees or related fields. And it was kind of through talking to them where that convinced me that, okay, maybe I should give it a shot. And so in my third year, I just very randomly, by chance, applied to a bioinformatics startup called DNA Nexus. And I just had no clue what a career in software engineering was, but I just applied and thankfully, they picked me, and I was able to spend the summer there building software pipelines for this, basically this platform that runs on AWS that helps people in bioinformatics run analyses. And that was, in my opinion, one of the key game-changing points of my life where I realized, wow, okay, what I'm doing is really cool. In software, you can build something and you can immediately see the impacts. And unlike, for example, economic development, it takes years or months or even longer for things to kick in and for you to see your work come to fruition. And so that's what really gave me that shift in mindset. And that's why I then pursued my master's in computer science, also at Stanford. And after graduation, I decided to transfer my scholarship from EDB to GovTech, and I've been working at OGP ever since. So, yeah, so that was quite a stumble, and I feel like things could have gone 1,001 ways and could have gone very differently from where I am today. So there were a couple of things I was reflecting on while coming up with this presentation. The most important thing was, if not for my friends or my peers who worked in software engineering and who just convinced me to just apply for an internship, I probably would never have thought of doing a career in software engineering in the first place. So one of the main things that I wish that I knew before that would have maybe convinced me to do a CS degree sooner would be if I had known what a career even looked like. So obviously there are tons and tons of ways that a software engineering career could look like. So depending on whether you work in a small company like a startup, where a software engineer could do anything and everything, all the way from like front end to back end, basically full stack, or even touching on machine learning or infrastructure. Or if you're working at a big company, what you're really going to do is very specialized. You're working on a small piece of the puzzle, but you're going really in depth into it, right? So I'm going to share my perspective, which is I would classify OGP as kind of startup-like. And so I'm going to talk a bit more about what I do and what I do on a day-to-day basis. Okay, so what do I really do at work? So I'm gonna talk a bit more about Isomer, which I mentioned was a government static website platform. And the reality is this is a product today, but it wasn't when I first joined in 2017. So when I first joined, I was actually completely fresh out of school. I had no idea what I was doing. And this other designer, Fiza, who joined exactly on the same day as I did, the two of us were put on a team together. And I had just graduated from college. Fiza had years and years of experience as a designer, so I was quite overwhelmed. And the problem that we were facing was, how do we improve government websites? So imagine this, right? There are just two of us, and we had to solve this pretty significant problem because a lot of government websites at that point, and I guess today still, don't really have a consistent user interface. And so people navigating, citizens or members of public navigating multiple government websites might find it difficult to navigate them because there's no consistent language or way of navigating. And I guess one of the major problems that we've dealt with was that a lot of government websites actually failed our basic internal usability checks. So what I mean by that is that a lot of these sites are not mobile responsive or were not mobile responsive, and they were slow to load, and they had issues like color contrast problems or font size issues that basically prevented people with visual impairments or visual issues to be able to access public websites, and that is a huge problem. So another thing that we discovered while doing this research was that many of our government websites ran on dynamic content management systems like WordPress. And for those of you who are familiar with WordPress, you'll realize that there are tons and tons of security issues being found every month. And if we don't patch them, these could result in hacks or problems like defacement in government websites, which is a no-go. And another issue that we had was that government websites are really costly. Even though it could be a small 10-page website, it could cost up to $25,000 per year to host. And on top of that, it takes months to procure because in the government context, we have to, there are a bunch of procedures in order to buy a service. And in this particular case, websites could take 1 to up to 6 months to set up, and just because of how onerous the procurement process is. So the solution that we came up with was, why don't we just use static websites? And in this, what I really mean is we use GitHub pages at the very beginning, and it's now moved off of that. But at the very beginning, we thought, okay, how about let's use this really, really basic thing called Jekyll, which a lot of GitHub websites use. And then we could create our own theme. So every single website that's built off of our template just uses this one thing, and it's just modifying existing components of the template. So that way, what we can ensure is that all the subsequent websites that are built on our template will be a mobile responsive site, would have decent usability. It would also have security checks and audits, because static websites don't really have an application server for you to attack, right? Because it's already pre-built, everything is just stored and distributed. So there's no real way to attack a static website. And finally, in government, we do have compliance clauses. So having a central template that is compliant to several clauses, or several of these compliance clauses, would then help agencies in reducing their workload. So that was our solution, and how we would get our agency users to edit the content is to use GitHub. And this is kind of what the content editor looks like. It's a bunch of text, and if you can see over here on the right, there's this thing called the hero banner, and in the middle of it is hero title. And how you would edit it is to go to GitHub, go to that specific column or specific row and modify it, and then hit save, and then your website will build, right? It seemed like an elegant solution, at least to software engineers, right? Because we're so familiar with GitHub, and to us, this is kind of our bread and butter, right? GitHub is great. You can have version control. You could open source it immediately, so everyone can see your content. There's transparency. There are all these like great ideals that we thought we were pushing for, until we realized that actually GitHub isn't the best. It's not the most friendly for people who aren't already used to it. So we ended up getting tons and tons of emails from our admin users, our agency users, being like, oh, hey, our website broke, what is happening? And then we realized, oh, shoot, okay, maybe GitHub isn't the best way for people to edit content, because some file types like YAML or like parts of Markdown are really, really sensitive to white spaces. So there's no room for error for your agency users to make. And even if they did make an error or a mistake, there's no immediate feedback loop that tells them, hey, what you're doing is wrong. Here's how to fix it. So this went on for a couple of months, and then COVID happened, so I was dragged off the project. But then when I came back, we decided to build a content management system. So we wanted to increase that feedback loop time so that someone could make a change and immediately see the change on the right side of their page. And this is the current iteration of the content management system. Another elegant thing about the solution is that you can you basically cannot mess up, because we've built the UI on the left to only work in a certain way. So you couldn't add random spaces or random hyphens where we didn't want you to, just because we prevented you from doing that. Awesome. So we rushed the system out. We got great reviews, but then now we were realizing that, okay, our code base is kind of a mess. Like, it works, but then we don't really know if things are going to break if we did modify it in a certain way. So I think by now you'll realize that when you write code, it's not just about writing the code, but it's about maintaining it, right? So the point in time when we had to take a step back was when our product manager asked us, hey, could we add this new feature in, and how long would it take? And the entire engineering team, which at this point grew to about 4 or 5 of us, we looked at her and we said, actually, we don't know when it will be done, because none of the 4 of us really knows how everything works, because we all wrote it in such a rush, and components were connecting to each other in ways that we didn't fully know what was happening. So we took the next step to refactor. And what refactor is taking this spaghetti code mess and really disentangling it and organizing it in ways that software engineers can understand and can talk to each other about. And in this way, we can take a huge file or a huge bunch of files and then really cleaning it up and making it more readable and palatable. Yeah, so by now you should have realized that there's kind of a theme in this whole software engineering career. And the main theme is that you go in, you want to solve a problem, and then you solve the problem and you realize, or rather you come up with a strategy and then you implement it and you realize, okay, there's a new problem. And then you come up with a strategy for that new problem and then you implement it. And then you have a new problem and you come up with a strategy and then you implement it. And even right now, at this point in time, there are other new problems occurring with this code base as well because we have more users, because we want to add more features. So software engineering career is kind of like this, right? It's cycles of finding new problems and finding new ways to solve these problems. So I guess that was a kind of a brief introduction to what my 4 years or for this one specific project was like. I'm going to talk about what I really do on a day-to-day basis. So right now I'm kind of in a role where I'm a tech lead manager. And what that really means is that I am both an individual contributor. I both write code for myself and by myself, but I also manage a team of software engineers. So I have 3 full-time engineers under my charge, and I'm responsible for their growth and development as engineers, as well as their work. So I'm going to talk a little bit more about my time allocation for this week. So I took a screenshot of my calendar, and this is a bit of a funny thing because in order to color code these calendar events, I kind of messed up the whole team's calendar. So I got a message from Sarah this morning being like, who messed up the calendar? Please fix it. So I hope you guys appreciate this. Yeah, so in my past week, for example, I spent about 30% of my time doing individual contribution work, and that's the stuff in green. So last week, for example, I was working on a new feature that was a security feature for the iSummer CMS to restrict file types and to sanitize specific file types for a specific upload flow. So that's what I did. I spend 25% of my time doing engineer management, and this is different from engineering management. Okay, so engineer management is more about personal development. So how do you help your reports grow into better engineers, and how do you help them figure out what they want to learn, what they want to do, and how to achieve that? I spent my time doing one-on-one sessions where I kind of do mentorship and coaching sessions with my reports. And part of engineer management is also doing hiring interviews. So figuring out like what is the team that you want to craft, who do you want on your team, how can you hire the right people? And on top of that, you want to figure out how can we empower our engineers better? Are there things across the entire organization that people are dealing with pain points, or do they have pain points that are similar, and how can we then figure out how to fix that? So that's engineering management. I spend 25% of my time doing engineering management, and this is basically ensuring that the tech is built well and that there is coordination. So for example, on Monday afternoons, we have our product sync ups, and that's when the tech lead and the PMs and designers and basically everyone on the teams will figure out what our priorities are for the week and figure out what to do, when to release these changes. And we also reprioritize at times. Yeah, we also talk about new features, for example, and like where do we want this tech product to go, and discussions on that. So the other 10% of my time is spent on miscellaneous meetings, and on our team, we do a daily sync up to signify the end of our day at about 5:30 p.m. So we do team sharings. Each product team will give an update about what they've done for that specific day or week. And on Fridays, we have longer team sharings where we invite speakers, or if we have interns, we'll do internship presentations, and we have a happy hour after that. And in the last 10% my time, I dedicate it to explicit learning. So our team has a culture of dedicating Fridays, or at least parts of your Friday, to learn something completely new. And this is, for the most part, protected time, unless you have a backlog of work that you want to finish. But for the most part, you're supposed to pick a topic that you never thought of before. It could be completely irrelevant to your work, or it could be tangential, or it could be related. And it's basically protected time for you to learn and to do whatever you want with it. Yeah, so that is a kind of a deep dive into what my week looks like. Yeah, actually, at this point, I wanted to find out if you guys had any specific questions about my what I do at work before I talk about how to become a better software engineer. Or actually, should I just continue? Oh, what is happy hour? I guess happy hour is, Sarah, would you like to share?
Yeah, so we used to do virtual happy hours. So we would do every Friday. We even did it Wednesday during circuit breaker. Basically, a chance for the team to get together and bond, play a game, or do some kind of activity. We try to keep that up. When we are able to do things in person, then we'll do something in the office. But yeah, it's just a chance for the team to continue to have a chance to talk to each other in a non-work setting, because especially with COVID and working from home, I think that's one thing that's been really hard to maintain.
Right. Cool. So there's a question about automation tools. So I think one of the significant ones that we use is, I guess, CI/CD. So we use GitHub Actions to help us automate the deployment process across all of our product teams. So really, OGP has 10 plus individual product teams, and each product team has engineers who are, or I guess engineers, PMs, designers, who are, for the most part, also working on other products, right? So basically, we see the same problems across different product teams, and then we come up with solutions that can benefit everyone else. So CI/CD is one thing. Smoke tests or end-to-end tests, these are some of the automations that that we employ to help us prevent breakages when we deploy our code. Yeah, that's great. Okay, Friday self-learning is not the norm. It is the norm, but I think I just wanted to point it out that it was explicit self-learning time. Any reasons for choosing GitHub over GitLab? Yeah, we just went with GitHub because we didn't want to host our own GitLab platform, so that was mainly it. Cool. So I guess this one's more about careers or like what the role would be like on OGP. I'll finish the rest of the presentation and then I'll come back to the questions. I think that would maybe help a little bit more. Cool. Okay, so in the final part of the presentation, I'll be talking about, I guess, pieces of advice I would give myself or anyone really to help become a better software engineer. So 3 pieces of advice. The first one is that this might be the hardest pill for a lot of people to swallow, but the reality is that in software, you have to accept that you'll never know everything. And even if you did know everything at this point in time, give it a day or two and you'll realize that a million other new ideas, concepts, problems, solutions, libraries, packages have been spun up at that point in time. So what you really have to do is you really have to embrace the imposter syndrome, because for people who aren't familiar with it, is the idea that you're thinking, why am I in this job? How did I get this? Or why am I in this career? I'm not good enough. The reality is everyone feels the same way. And you'll just have to really adopt the growth mindset and keep learning. So I think one of the common themes with a lot of engineers is that we get really overwhelmed by the amount of information that we have to pick up, or the fact that our ground is literally shifting every single day. So my biggest piece of advice is to take it slow and learn one thing at a time. So to really, even if you have 10 new things you wanted to learn, you have to be structured about it and pick one thing and learn it and then move on. And how you can do that is by creating fun learning experiences for yourself. For example, you could learn a new technology while solving a really, really silly problem. And one way to help you crystallize your learnings about these new technologies is to write notes about it. So what I did was, I did, and I guess I still do, write blogs. And so what I did was, I wanted to learn about this thing from Google called AutoML. And AutoML is basically an automated way to run machine learning pipelines. And it can help you solve very simple machine learning problems. And I learned about this at a conference. So I decided to write a blog post about how I made a machine learning chicken rice classifier in under 4 hours to tell me what type of chicken rice I bought for lunch, which is silly because obviously I bought the chicken rice, right? So I knew if it was roasted or steamed for sure. But I wanted to make a really silly problem to solve and kind of test out this new technology and then write a fun blog post about it. Another thing I did was, I was also quite bothered by the Straits Times forum, so and how some of the comments or opinions were just really hilarious. Like someone was saying that it was very unsafe to sew on trains, and how could this be allowed, basically. And so I wanted to find out, okay, is there a theme to the the voice, like the way people write their Straits Times forum articles, right? Like a lot of people are very angry about it, right? Or they have very, very fixed or well-defined points of view. So I wanted to figure out, could I build a program that can speak like the collective voice of the Straits Times forum? And I did this using a technique called Markov chains. And I basically, spent some time on a Saturday or Sunday and just wrote this fun little thing. And it helped me learn more about how Markov chains work, and also learn to implement it, and had a fun time working on it. Cool. So the second piece of advice I would give is to get better at problem solving. And this sounds really silly, right? Or it's very duh, because in software engineering, you have to solve problems. But my point is that actually, in a lot of times in software, most problems have been solved to its death. Like one single problem, like authentication, you solved it so many times. You could use a session, you could use a cookie, JWT, whatever, right? But the reality is, in order to be better at solving problems, you need to be able to solve it in an optimal way under a very short period of time. And in my opinion, there are two possible ways you can do this really well. The first is, you've either attempted to solve it before, so you've seen the problem, you've thought about, okay, what are 3 or 4 ways that I can solve it? What are the pros and cons of each of these? And then since you've had that experience before, you would just pick the best one. But if you haven't done that before, someone else must have, right? So you could reference a bunch of people's solutions and then figure out, okay, these are 3 case studies I've seen, what works for them, what doesn't work for them, does this work in my case? And if you go through these processes multiple times, you'll be able to realize that, hey, I'm being able to solve problems much faster in ways that are more efficient. So specifically, what can you do, right? So my biggest piece of advice is to be intentional when solving these problems, because it's easy for us to, when we see a problem, immediately jump to a solution and pick that first solution and implement it without being considerate about why I'm doing this. So what you really want to do is to enforce structure on yourself and come up with as many solutions, even though they could be very infeasible. And after you've brainstormed for a bunch of solutions, narrow them down by talking about the pros and cons, and then having this structure would really help you grow. And finally, what you should do is you should crystallize your learnings in design documents. So in our team, we do these things called design documents, where we document why we made a specific engineering design choice. So for example, this was a thing we worked on 2 weeks ago, Alex and I, and we were thinking about how can we better unit test our backend, right? And we were running into certain problems, and then what we did was we looked at 3 different ways 3 other products on OGP solved this problem, and talked about the pros and cons and why it works for each of their cases and why does it not work. And then we took a step back and we thought, okay, for isomer CMS, what do we really want to do? And why does this work for us? Why does this not work for us? And we write it all down because humans have a short-term memory and we always forget things if we don't write it down. So in 3 years from now, when we look back at this, we will know, okay, we made this decision. Why did we make this decision? Even if it's a silly decision, like a dumb one, we know why we got there in the first place. Cool. And my final piece of advice is to practice technical communication. So in my opinion, star engineers who cannot talk to each other or work with other team members are useless. And your work is only useful if the next person can read it and understand what on earth is going on. And really what you want to do is to show and not tell. So what can you really do? The first thing is to gain experience working in teams. So I know that a bunch of folks attending the talk today are mostly freshmen or sophomores, so like for second year students, and you may not have had internship experience. So what you could do is you could contribute to open source projects. And I think open source projects make it so much easier to learn about communication because you've never met some of these people that you're going to work with before. And so you need to take the extra effort to figure out how to best communicate the ideas that you're trying to put forth in written form. And that could also be visual or in text. And so that's something that you should really practice. If you have the chance to do internships, you should, because that's another way for you to figure out how to work in teams. Like, what is the dynamic like? Who do you talk to to review your code? What are the standards, right? And so all of this is all practice for communication. Another point about open source is that Hacktoberfest is coming up, and Hacktoberfest is kind of a period of time in October where all open source projects will highly encourage you to give contributions to their code. So that's something that you might want to think about. And finally, this is very general, but it's great to practice explaining things using visual aids. I think one of the biggest pitfalls of software engineers is that we talk about our solutions and we don't really write it down or visually explain it to someone else. So what we think makes sense to us in our heads may not necessarily translate to someone who is not in your head, and that's everyone else. So what I mean by that, let me just hop onto this point, is that you should use visual tools to collaborate with other team members. So for example, on the Isomer team, when we're talking about how should we name our endpoints, sorry, not endpoints, your individual page URLs, we collaboratively work on this tool called FigJam, where everyone can post notes, we can write our comments, we can do thumbs up, thumbs down, and that's effectively a good way to communicate visually how you're thinking about things. Another thing you can do is when you're writing code, you shouldn't just make code changes, but you also have to explain your code changes. So for example, in GitHub, when you make pull requests, you should always follow some sort of structure. Like you should describe the problem, you should describe your solution. You should also have a checklist of tests so that the people reviewing your code know or are confident that you've actually done your work, and they also are confident that they can test your code without breaking production. Yeah, so I guess that's my tips for how to improve as a software engineer. If you guys have any questions about OGP or our internships, our careers in general, please feel free to reach out, or you can go to open.gov.sg for more details. And yeah, I think that's all for me. Yeah, okay.
Yeah, and I just wanted to point out before we go into the Q&A, if you are interested in learning a little bit more about OGP, we're holding a webinar next Friday at 3 p.m. We'll be talking about how we build our COVID-19 vaccination booking system. So we'll be having product manager, software engineer, and product designer there. Feel free to sign up. You can scan this QR code, or you can go to go.gov.sg/vaccination operations webinar to sign up. So hope to see some of you all there. But I think that's all for us, and maybe we can transition to the Q&A. Pass it back to Joelle.
Okay, thank you, Preston, for the sharing. Maybe I will share screen.
Cool.
Okay, so these are the questions that we have gathered beforehand. Then maybe the rest of you can also scan the QR code to submit any additional questions you guys have during this sharing. Yeah, or to vote for questions that you want.
Cool. So which one should I go for first? Like top down?
Yeah, I guess.
All right, cool. So why did I decide to join GovTech? So I was mentioning earlier that I started off knowing I wanted to do public sector work. So the career for software engineering came to me later when I was in college. So that made sense for me because GovTech is one of the best places in public sector to do software engineering work. Is there a possibility for a winter internship? Yes, we do have positions for winter internships, but obviously the summer internship positions are going to be more. So, but please feel free to go to open.gov.sg and look at our openings and apply. What are the prerequisites to work as a software engineer? I guess the biggest prerequisite is that A, you have to code, but B, you also have to be a strong communicator, as I mentioned in the presentation. Can computer engineering students be good software engineers? Yes. You don't necessarily have to be the most like formally fully trained in software engineering, but some of the concepts do matter. Things like algorithms, runtime complexity, space complexity, how to abstract your code. So as long as you're able to write code and to be able to think about why and how you're writing code, I think you'll be a good software engineer. Do you have to specialize or generalize to have better chances in the industry? So this one's a really tough question to answer because it really depends on what you want to do. The industry is huge. There are roles, for example, you could be really specialized in VR, software engineering, or you could be a general software engineer like I am. I do mostly web development, which I would consider quite general, and I do front end, back end, infra as well. So I think it's a big industry. You can really take your time to explore it. What's the hiring process like? So I'm assuming this is more about full-time employment and full-time software engineering specifically. So we start off by having a resume screen. We'll take a look at your resume and then we'll send you online coding tests. And if you do well in the online coding tests, we'll invite you to in-person coding tests. And I guess pre-COVID times it would be physical, but now it's all online. So what we do is we give you two technical questions that you can solve within 2 hours. And then finally, if you do well in that round, we'll forward you to our director, and then it'll be kind of a fit interview and figuring out why you want to join us. Does it make sense for you? Yeah. Okay. Are there any AI-related projects in OGP? Yes. We do have a data scientist, and we do have software engineers who are also data science, who have interests in data science and machine learning. I would say that AI for us is a tool to solve a problem in other products. So there's no single project that is like, this is an AI project, but it could be a feature in a wider product. Like, for example, in Homer, one of the problems that we had was how do we figure out if the people submitting location reports and health reports are indeed the right people who are supposed to do it. So for that, we employed face recognition technology for that. But we don't really, but that's the way we see AI playing a role in our products. Yeah. Another product that we have is Scam Shield, which is a product that helps filter out scam SMSs from scammers. And in that specific case as well, we have machine learning technology to figure out which of the SMSs are scams or not. So yeah, they're all features. How's the work-life balance? I think it's pretty good. As you can see from my calendar, my days usually start at 10 and we usually end by 6. But of course, in software, if stuff goes down, if stuff breaks, you have to fix it. And because we work in government, it depends on the circumstances as well. So because we were working on COVID-related things last year, we worked really, really hard, and that involved late nights, weekends. But I think we were compensated by days off after that. So I would say the work-life balance is good. It's quite manageable. Yeah. What's the most important skill as a software engineer? I think I might have covered this. The most important skill to me is coding, but then after that, communication. Would being a front-end, back-end, or full-stack engineer give me the best chances of interning at OGP? I would say being a full-stack engineer gives you the best chance because our teams are really lean. So for the most part, our teams have between 1 to 5 software engineers per product. And so what that means is that you are going to have to learn to do everything. But the reality is as well, when we do internship interviews, we don't necessarily look for experience doing all of it. We just want to know that you're able to pick it up and we can train you on the job. What would you recommend for a person who'd like to transition to a software engineer role from another tech role? I think the biggest thing, I guess I did kind of come from that background as well. I think you have to figure out what you want to do, figure out if you enjoy it, and then come up with fun projects for yourself to crystallize your learnings. And that's really the best way to learn. Okay, what are some CCAs or extracurriculars that you need to do to get internships? Actually, I don't know if this is necessarily important. I think just do whatever you want to help you grow and be able to solve code problems and build products. What are some of the useful knowledge in uni that are useful in the workplace? This is tough because I don't really know what the curriculum is like and what program you're in. But I think some of the fundamentals are there. So things like how do you abstract code, things like complexity, things like databases, things like web applications. But I think the most important thing is to learn how to learn, because really when you go to uni, you learn how to use Google. Yeah. Okay, what's the interview assessment like? I think I covered that. The next one is, does OGP believe that whiteboarding is the best and fairest process for selecting the best developers? This is a loaded question because hiring is always difficult, right? And some people perform well under pressure, some people don't perform well under pressure. I think, in my opinion, whiteboarding for us is not necessarily the best, but it is the best that we can do. And how we try to make it better is we try to make it a non-threatening environment. We try to make it a very safe space. So in our interviews, we're trained to kind of make sure that you can either code and talk at the same time, or you can choose not to talk at the same time if that's your style. You can pick whatever language you want, and your interviewer will do the best to understand how you're thinking about things and how you solve it. The reason why whiteboarding is so important to us is because we think it reflects the way that our engineers work with each other in real life. There are a lot of times when we do pair programming where one engineer is writing code and the other person's like behind your back and driving, like in the back seat while you drive. So that reflects a lot of how we work in real life. Okay, are self-learning days the norm across companies in this industry? I'm not sure. I don't think it is. I think it might be in specific companies, but yeah, for the most part, no. Okay, what's OGP's pay range? What? I'm not really sure how to answer this. We do have yeah, I think Sarah will cover it in a bit. Our pay range is publicly known, but I don't have the exact details.
Yeah, I would just say that we pay very competitively, so we try to benchmark with top companies in the industry. So, for example, Facebook, Google, Amazon. Whenever we work on our salaries, we try to make sure that it's competitive with these companies.
Yep. Yeah, I'm not sure if we post it publicly on our website.
Yeah, it's not on our website, okay. But yeah, I mean, we're happy to talk about it openly. But yeah, it's quite competitive.
How's my experience picking up programming since I was from bioengineering? Yeah, it was definitely overwhelming and very daunting. But I guess what really helped me was in bioengineering, we had to take a full year of computer science. So basically entry-level computer science classes. And that helped me speed up my learning. But what really helped me was side projects and finding these fun little things I wanted to learn about and make it fun. And I think that's how I grew the most. is lead code or CRUD projects valued in OGP? I don't really know what the question is really asking. But yes, I guess CRUD projects are valued because a lot of times things we're trying to solve can be boiled down to CRUD problems. Yeah, like even vaccines, right? Like the vaccination program, it's kind of a CRUD problem. You want to find out if someone's vaccinated, it's a read operation, right? You want to create a new vaccination appointment, it's a C, right? Create thing. So I would say that a lot of problems are CRUD problems. Cool.
Are there any additional questions? If not, I'll stop the share here. So
Okay, yeah, I think then if there are no other questions, sorry. If there are no other questions, I think we can end the session. Yeah, so thank you so much, Preston and Sarah, for this collaboration and the sharing. I think I feel that I learned a lot, not just like learning practical steps of how to pursue this interest in software engineering, but also learning how to learn and discovering your interests. Yeah, so I do hope that the rest of the participants, you all have taken away something today. Yeah, and we have actually a feedback form. We hope that you can actually help both EnginClub and OGP, yeah, with the future events that we will be holding, yeah, to cater more towards what you, the audience, would like to hear. Yeah. So with that, I think, yeah, we can end. Sarah and Preston, is there a way that they can connect with you or like OGP if they're interested to find out more? Maybe they can have a contact or feel, I'm not sure how, or go to your publicity, I mean your platforms. Is there any?
Yeah, so
Oh, sorry, I'm gonna, yep, go for it.
Yeah, so you can reach out to recruiting at open.gov.sg, or if you go to open.gov.sg, you can find out more about our roles. And if you want to directly apply, I'll send the link here, but it's go.gov.sg/join-OGP.
Yeah, and if anyone wanted to forward any questions, you can reach out to me at preston@open.gov.sg. Just note though, my work email gets overrun by GitHub emails, so I might miss your email or it might take a very long time to reply.
Okay, sure. I will send this into the Telegram group and just drop an email to them as well. Yeah. Okay. Yeah. Is that feel free to leave the session. Yeah, we can end or stop the recording as well.
Thank you all.